Hello and welcome to another section in further mathematics. In this section, we'll be looking at mechanics and vector geometry. But before that, let us look at the previous lesson. Okay, welcome back. Now, when we talk about mechanics, as in talking about the vector geometry, there are so many things we really need to take into consideration. Now let's go into detailed analysis of what we have right in front of us. We discussed something the last time about mechanics. I told you something about dynamics and statics. Now today we want to talk about the scalar or dot product of two vectors. Now the scalar or dot product of two vectors A and B is written as, so it is usually written as A dot B. It's pronounced as A dot B. Therefore, A dot B is equals A B. That's the absolute value of A times the absolute value of B times the cos theta, the angle between A and B. But I would like you to also recall that when you talk about vectors, you know, when you're multiplying two vectors that are in the same coordinate, the value of each coordinate is equals 1. Like if you have the I dot I is equal to 1, J dot J is equal to 1, and K dot K is equal to 1. But in a situation where you have I dot J is equal to 0, if you have J dot I is equal to 0, these are some of the rules we really need to take down when we are dealing with multiplication of a vector using the dot product. Now, with this, we say recall that I and J are mutually perpendicular unit vector. Hence, I dot I, just like what I explained here, is equal to x cos 0. So we have 1. If it is I and J, then it is 0. If it is J and I, it is 0. If it is J and I again, this is J and J, not J and I, this is J and J, is equal to 1. Hence, A dot B gives you A1 B1 plus A2 B2. That is to say, when you have two vectors, you only multiply the terms that are in the same coordinate with each other, then you get your sum, total value of the vector. Let's start by explaining. Let's call this our example 1. Let's use this example in getting what we are trying to say. For example, if we have find the scalar product, find the scalar product of the vector. The vector is A equals, and this is a bracket, 9I minus 2J plus K. These are A. And B is equals I minus 3J minus 4K. Now I want you to find the dot product. You can call it the scalar product or you call it the dot product. Now if you want to get the dot product of what you have here, remember the rule. I say you only multiply, you get the dot product of what, as in two vectors that have resemblance. So this you cannot do 9I times any other number. You can only multiply 9I by I. So 9I times I, remember I times I is 1, then 9 times 1, so we have 9 here. Now minus 2, J times J is also 1, so minus 2 times minus 3 gives you plus 6. Then we now have K times minus 4K. So let's do K times K is 1, and 1 times minus 4 is minus 4. So a total becomes 11. 6 plus 9 plus 6 is 16. 15 minus 4 is 11. So the dot product of this vector is equals 11. Now always remember that the dot product of two or more vectors is not usually a vector, is just a whole number. But when we get to cross product, then that is when you see that the cross product is also a vector. But the dot product of every given vector is usually a number, it's no longer a vector. Now I would like us to try this with let's go into solving example 2. I want us to apply what we just studied. Now he said if A is equals 3I plus 2j and B equals minus 4I plus 2j and C is equals I plus 4j. Now we want to find A dot B, A dot C and A dot B plus C. Now let's go to the first one, which is our A, that's A dot B. Remember the rule, we only multiply where we have equal coordinates. So we have A and this is our B. So our A plus B will now be the vector, will now be this vector 3I plus 2j multiplied by minus 4I plus 2j. Now what we now have is 3 times minus 4 is minus 12. 3 times minus 4 is minus 12. And I times I is 1. And you can't multiply 3 by j because it gives 0. So 2 times 2 here is 4. So plus 4. So our answer is minus 12 plus 4, which is equal to 8. As simple as that. Now the second one, we now have A dot C. And the value of our A is equals 3I plus 2j times the C value here is I plus 4j. Now we go into 3 times 1 is 3. 2 times 4 is 8. So plus 8 is equal to 11. Now we go up to point C. But before we do that of point C, let's look for the value of B plus C. Now our B plus C is you're adding these two. We have minus 4 plus 1 is minus 3I. Then 2 plus 4 is 6j. Now this is B plus C. Then we want to multiply it by A. And the value of our A, becomes 3I plus 2j. So the answer is minus 3I times this is minus 9. Then 6 times 2 is plus 12. So 12 minus 9 is equals to 3. I think with this we've come to the end of dot product, of analyzing some important points when it comes to dot product of a vector. But to refresh your memory on what we've just learned, I would like you to take the test that you'll be seeing on the screen shortly. Do well to always use this lesson note on the platform for a better information on the topic we've discussed.